My name is Daniel. I'm an engineer on the community team at Datadog. Hopefully you've heard of Datadog. This talk is not about Datadog, but if you're interested in what it is that we do or what it is that we'd like to sell you, feel free to hit me up after the talk. I'll be around for the remainder of the day. So at some point, we're going to see a slide that's going to come up, and the slide is going to say Principles of Observability. And that's the subject of my talk. We're going to talk about the word observability. It is a big word, all right? It's got a lot of letters in it. It gets thrown around a lot in our industry. And so I want to talk about what that word is, what it means, and crucially where it comes from. Because, again, it's a complicated word. It's an overloaded word. And in order to describe what the word is, because it's so complex, because it's so overloaded, it's actually much easier to talk about what the word isn't. That's the best place to start. So the first thing that I want to talk about, okay, is that observability and monitoring aren't the same thing. Let's talk about monitoring. Now, I say this as somebody who works for a company that's in this space. Observability and monitoring are not the same thing. They're just not the same thing, all right? Now, monitoring can be part of a broader observability strategy. Monitoring is good and true, and you should have a lot of it. But monitoring and observability are not the same thing. And that's something I'm going to come back to a little bit later in this talk. But I want to dispel that myth right away with you, right here, right now. Keep this in your head. Observability and monitoring are not the same thing. I also want to talk about dashboards. And I say this as someone who likes dashboards. All right? I stare at a lot of dashboards. I like to make dashboards. Dashboards are a lot of fun. And since we look at or observe dashboards, that must be observability, right? No. Okay? Just because you have dashboards, just because you can make dashboards, doesn't mean you understand or are implementing an observability strategy. They're a tool. Okay? And we're going to talk about the difference between those two things a little bit later on. But here again, just to dispel this myth right away, dashboards and observability, not the same thing. And since we are at DevOpsDays, now this is not a comparison most people would make, but I do want to bring it up. Observability and DevOps are not the same thing. All right? They are unrelated to each other in a fundamental sense. However, in the world of DevOps, there is an acronym that we love. 4 letters. C-A-M-S, the CAMs. We put them in that order because if we put them in a different order, it would be scam, and that's a very, very difficult thing to market. So we call it the CAMs. Culture, automation, measuring, that's an important one, and sharing, also an extremely important one. That acronym, these fundamental elements that make up what DevOps is, actually fit extremely nicely within the world of observability and when you're implementing an observability strategy. Now, although we are here at DevOpsDays and Statscraft, this is not fundamentally a talk about DevOps, so I'm not going to mention it again. But if you are interested in how these two things work very nicely together, would love to chat more with you about that. So now that we have established what it isn't, and I mean, it's not a lot of things, but those are some big ones that we've established that it is not, let's talk about what it is. And before we can talk about what it is, I actually want to take us back through time a little bit. We're going to do a brief history lesson. This thing you see up on the screen right here is a centrifugal governor. Okay? Now, if you're into old sci-fi movies or you're into steampunk or you're into steam trains or anything of this nature, maybe you've seen one of these before. Now, what is this thing? This thing was invented like in the 1600s, all right, by Christopher Huygens, who's possibly best known as being an astronomer. He's the person that figured out that the rings of Saturn were actually made up of particles. They weren't solid things. It's actually really cool. But like a lot of naturalists in that period in time, he was basically an expert at everything, because a couple of hundred years ago, you could be an expert at everything in a way that's very, very difficult to do now. And he invented this, and what this thing does is it spins around real fast. And when it spins, and it's very heavy, and it expands, and the balls, they go up like this, and it slows down the balls, they go down like that. And that's how it works. And it's used to govern the amount of steam going through a machine. In this case, it was to govern the distance between gears in a windmill, something like this, right? But the point is that it's a self-governing device. It's a device that regulates the flow of a thing. And now to us today, we think, well, yeah, I mean, that's normal. This was groundbreaking at the time. Somebody had to invent this, right? And so, although we understood more or less how it works and what it does, an actual analysis of it didn't come around until this fellow, James Clerk Maxwell. Basically, everything we can enjoy in the modern world today is more or less as a direct or indirect result of something this guy discovered or did. When you talk about the great physicists of all time, you've probably heard of Newton, right? Newton's a big one. You've probably heard of Einstein. Einstein's a big one. Maxwell is in that list, all right? He gets forgotten about, which is unfortunate. I would need an hour just to do a bullet point list of all the things this guy discovered, proved, wrote about. It's amazing. But what is germane for us here today is that he wrote a paper on how the centrifugal governor works. Not what it does, but how it works. Nobody had ever done this before. It's very, very interesting. And as a side effect of this paper, it wasn't even the point, a whole new field of study emerged. And that field of study is called control theory. Now this is where, if I could actually see the audience, I'd say show of hands, who here, and we'll do it anyway, who here has heard of the word observability, ever? In the context of your job, exactly, basically every hand goes up. Who here has heard of control theory? Many fewer hands. And this is the crux of the issue, right? Is that we all think we know what observability is. But if we've never studied control theory or even looked into it, turns out we probably don't. So you're thinking to yourself, okay, Dan, why the history lesson? Like, we're talking about computers, those are new things, why are we talking about spinning balls? Fair, all right? I say this to establish a point, that control theory, which is where observability comes from, is a well-established field of study. It's been around for a very long time. A lot has been written about it, and a lot of, in fact, how our modern world works and functions today, everything from plumbing to spaceships and so forth, are made possible because of principles proposed in control theory. And so we're going to look at a tiny little itty-bitty snippet of it for us as practitioners. And that is this idea of observability. But before we can even get to that, we need to talk about something else. And that's this word, the controller. So the controller is the thing in the world of observability that's actually, collecting data, right? So what do I mean by that? Well, we talk about, control theory and this idea of control theory and this idea that, this vast body of knowledge, and it has a whole big definition that we could get into, but I want to get into talking about the controller. The controller is a thing that's theorized by control theory. And it's the thing that actually takes measurements. It takes measurements. And it takes those measurements at a point in time. A value at a point in time. That sounds familiar, or at least it should, because we work with values and points in time all the time. They're called metrics, right? We work with metrics all the time. So where does this idea of metrics actually come from? It comes from control theory, as it turns out. And the controller is the thing that actually takes the measurements at that point in time and it compares them to a reference value. Compares them to a reference value. And the delta, or the difference between the measurement and the reference value is, get this, called an error signal. We've probably heard of that one as well. We talk about the 4 golden signals, right? We talk about things we need to know in order to understand our systems. Where does that term come from? It comes from here. So we're learning all sorts of cool things today, right? So the controller takes the measurements, compares it to a reference value, measures the delta, then does what? Attempts to take corrective action. That's the control part of controller. Attempts to take corrective action to move the system towards the reference value. And to do so in a way that doesn't blow everything up. Okay? So what does this mean for us? Well, we've got metrics, we've got error signals, and we've got something we're trying to achieve or move towards. An objective. A service level objective? Yes, as it turns out. So here we got this term as well. Where is it coming from? It's all coming from here, right? So it behooves us to understand this stuff because it helps us to understand what we're doing as practitioners today with our own systems. This is the bog standard definition of observability. If you've ever run across this term before, this is probably the definition that you've heard, that observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs, right? Each of those words means something extremely specific. And without an understanding of what those words mean, we can't actually understand what this phrase even means. And if we can't understand what this phrase means, then what the hell are we even doing? Right? Are we actually doing observability? Is our strategy what we expect? Is our tooling doing what we want? How can we tell? So let's start with the word measure. Measure means, well, it has a dual nature, right? So the first definition of measure is a quantity, a value, right? How much something weighs. We'd be fairly familiar with this, right? How many items are in our Redis queue, right? How full is our hard disk? But it also has a second, higher order definition, and that is the impact or the value of something. And this is actually super, super important within the context of control theory, this idea of basic and higher order definitions for things, because they get mixed together and used in ways that are sometimes a little bit unexpected. And a lot of tooling that we have available to us as practitioners today don't well define these differences very well. And this can be problematic if you're not expecting it. So measure has a dual meaning. It's either literally measuring amounts or measuring value or impact of a thing, which then of course relates to service level objectives and AIRs and so on and so forth, right? So it's all very good. We'll talk about state. State in the English language is a super, super overloaded term. So the definition that we want is the condition of a thing at a specific point in time. The condition of a thing at a specific point in time. But again, here, we're talking about measuring, right? We're talking about values and we're talking about points in time. It's super, super critical, right? So we're talking about, once again, metrics. Incredibly important concept of observability to understand this idea of state. But you need to be able, and this is the second part that's important, is measuring it at a point in time. You have to be able to measure time correctly. If you cannot measure time correctly, and this is an incredibly difficult problem to measure time correctly, if you cannot measure time correctly, then that's the only problem you need to solve. Literally no other problem is more important to modern infrastructure than accurately measuring time, and that is the hill I will die on. Take that one to the bank. We'll also talk about systems. What's a system? This is another big word, right? A system is an interconnected series of components operating as a whole. Fair enough, right? But again, in the world of control theory, everything's got a higher order meaning. And so for us, we can also talk about the system as being literally the complicated thing, or it could be a way of describing or abstracting that complicated thing. And once again, we see where we start to run into problems as practitioners with our tooling, with our consoles, with the things that are available to us to help us analyze our own deployments. Does the tooling expect the system to be literally the thing, or an abstraction of the thing, or some weird combination of the two? Got to figure that out before we can actually start to use that tooling in ways it's intended. Or it's just bad tooling. That happens. Knowledge. Knowledge. This is a big one. I'm going to need more than like 15 seconds to define the word knowledge. Probably a PhD would help. Let's go with the simplest possible definition, that it is the sum of what is known. The sum of what is known. But even in that simplest possible definition, there's so much more there to unpack, right? Like, what even can be known? Right? What does that even mean? And in the context of control theory, we talk about knowledge, we talk about the sum of what is knowing. What we're actually saying is what it can be demonstrated to be true. And that's critical. What can be demonstrated to be true. Not what we feel, not what we hope, right? Faith-based deployments? No. Okay? Right? You have to be able to demonstrate truth from data. That's an incredibly tricky concept. Ultimately, that's what we're talking about. We're talking about knowledge within the context of control theory. We also have the word output. Output's extremely important. Now, when control theory was first postulated, this referred to like how much fabric a power loom could produce in an hour type of a deal, right? For us here today, we're talking about output, we're talking about data, right? The data that is produced by a system, the data that we can observe as it leaves that system. And as it leaves that system, hopefully it's doing so in controlled ways. Hopefully it's doing it in ways that we actually want. A lot of data leaves your system in ways that you don't expect. We had a speaker a couple of talks ago who gave a lot of examples of data leaving systems in ways you don't expect. Terrifying stuff. We talk about output in our talks. We're talking about the work of a system, right? The actual work of a system. So that one definition there is incredibly complicated, as it turns out. And so if we just go to Wikipedia and you read that definition, we go, oh yeah, I get it, that's fine, something about like, measuring states and blah, blah, blah. No, we have to go deeper, And control theory is extremely vast, and we don't all have to become experts in this field of study. It's outside of the scope of the work that we do, and that's okay. But the context is important, and control theory is vast, and before we can get to the heart of what observability is, we're not even there yet, right? We have to talk about this word, this is state observer. This is a super, super important term. Because the state observer works with the controller. The state observer is the element of the controller that's actually doing the measurements. It's actually taking all of these good things that we're talking about, right? And it's packaging them as data. And that data can then eventually become knowledge. Each of these principles is extremely important. First, we have to collect the data. We have to do it in a controlled way. And that data on its own is not yet knowledge. It's just data, right? We have to be able to demonstrate truth from that data. The state observer helps us to do that. Okay, so the idea of a state observer is it's taking these measurements and it's providing data in a way that we can then turn it into knowledge. But wait a minute, how do we do that? Like, I don't know about you, but I can't read binary, right? My assembler is weak, okay? So I need layers of abstraction there. The state observer helps us to get those layers of abstraction, right? Whereas the controller is literally taking the measurements and moving us towards corrective action, the state observer is now providing us with layers of abstraction, and this is important. Very, very important to what we do as computer people. We love abstractions, right? So state observer, keep that in mind. Now, in the world of control theory, observers, okay, are basically just math and algorithms and matrices that we converge and so on and so forth. So I've listed a couple here of my favorites. Now, if you're the sort of a person who looks at this and looks at the background and goes, oh yeah, okay, I see what's going on there. We're just doing some like delta equations. We're going to converge that onto a matrix, and that's fine. Like, okay, cool. It's basically just calculus. Super. You're well on your way to becoming an expert in this field. But if you're the sort of a person that, like me, does not have classical training in mathematics, and you look at that and you go, oh, good God. It's okay. We're going to take a deep breath. We're going to push the math out. We're going to center ourselves. What can we as practitioners, as SREs, as developers, as operations people, as product owners, as whatever you're doing within the context of your professional obligation, what can we actually take away from all this talk about theories and controllers and all this stuff? It's complicated stuff. Well, we could talk about the 3 pillars, I guess, right? The 3 pillars, logs and traces and so on and so forth. I don't really like to talk about the 3 pillars. I think it's an outdated definition. It's important to note because you see all the times in blog posts and documentation, especially marketing material, talking about the 3 pillars of observability or like whatever. Okay? It is important, I guess, to think about because the first time that we as an industry sort of started to think about observability and monitoring as being separate things. So it was a good tool on the pathway to understanding observability, but now we've sort of moved beyond that, because now we have a lot of other different sorts of signals. We've got other different ways that we can collect data. And that's good and bad, right? We have more data now than we ever had before, but it's a double-edged sword. We talk about events, we talk about signals, we talk about telemetry, user paths, user stories, right? It's not just about literally what can we measure, using an agent on a machine, but also like what are our users doing? What can we tell about that? That's all part of that strategy. We talk about observability as practitioners. We have to talk about understanding, and we have to talk about comprehension. These are separate things, believe it or not, right? And this is where we get to the heart of the difference between monitoring. Monitoring is about things you already know. It's about understanding the things you're already aware of. Observability is actually about comprehending what these systems are doing and how they're working together. And this is a subtle but important difference. They're related, but they're not the same thing. The unknown unknowns. This is what we talk about. We talk about observability. We're talking about what we don't already know. And this is really the difference between monitoring and observability. I said we'd get back to this. At the start of the talk, I said we'd get back to this. This is where we're going to get back to it right now. The monitoring is about what you already know. You already know you have hard drives. You already know you've got, like, edge routers. Right? You already know you have Redis queues, and those queues are filling up, and they're on different shards, and like one of them is blowing up, and you can't do when, you can't empty it, and it's driving you crazy, and the pagers are going off. But you already know that. That's what monitoring is about. Right? Because you can't monitor things you don't already know about. It's not how it works. Observability is about unknown unknowns. It's about asking questions you didn't even know you could ask. Because you didn't have a way of accessing that data and working with it in abstract ways, in arbitrary ways. And that's what observability ultimately unlocks when you get down to the heart of it as practitioners today in IT, in technology. It's about unknown unknowns. It's about exploring new facets of your infrastructure and your deployments. So we talk about observability, then practically speaking, as us, as computer people, that's what we're talking about. We're talking about accessing new information based on data and coming up with new truths that we didn't even realize were possible. You may have heard the phrase, you have to look at both sides of the coin. Well, we talk in our cloud-native, microservice-based world. That coin has like 72 different dimensions. It's impossible for a single human being to hold it all in their heads all at once. And so observability is going to unlock that potential. That's the idea, at least. That's the promise. And the super important thing here is that there's a relationship then, and this is what I've been building towards, between what is being observed and who is doing the observing. And this is where we actually start to step away a little bit from traditional control theory. And this is where we, as IT people, can actually start to make our mark and start to do interesting and new and novel things, right? We like to innovate. That's everybody's favorite word. We got to innovate. Well, how can we innovate within the world of observability? This is where you can do it. Start to respect the fact that the observer and the observed share a relationship, and that relationship, if we can codify it, if we can build for that relationship, brings us new insights, brings us new ways of understanding our own deployments and our own infrastructure and our own businesses in ways that we just didn't have before. And that, I think, is really, really cool. So ultimately then, you, and I literally mean you, as a person working in IT, are more than a state observer, right? You're more than just a cog in the control theory machine, right? And that's what you bring to the table. That's what makes you powerful and interesting, right? As an element of this equation. That's where you can bring value into this conversation, okay? As we can start to talk about more than just disks filling up, and we can start to talk about things like business value and like correlating, engagement and all this cool stuff that business people want to talk about. But we can talk about it using a common language. And that's actually really, really cool, right? So I'm going to submit this as a talking point for us here today. And when I say for us here today, I meant yesterday, because I did this talk yesterday morning. But we could talk about it again this afternoon if you still want to. That observability as a property of a system is important. But so is the consumer's capacity to make use of that property. And that's what takes us again away from traditional control theory. So the last thing I want to say is this, that the next great leap forward for us as computer people bringing value to our organizations is that we're going to look beyond monitoring, we're going to look beyond graphs, we're going to look beyond dashboards, we're going to look beyond pagers waking us up in the morning. And we're going to start to have unifying conversations within our own organization, with our business people, with our product people, with our legal people. And we're going to do it on top of this beautiful new world that we now understand about observability and what it means. And we can actually start to ask questions now because we now have good ways of understanding our tooling. We go, wait a minute, this thing that we thought we had before, turns out I can't ask questions in arbitrary ways. I need something different. And I got to look for what that different thing is. And maybe that means I got to build the next great thing. So if you're looking to build the next great thing, maybe the next great thing is literally in this space, because that's what's going to set us up for the next generation of innovation. Thank you very much, everybody.